Right, so I'm calling this video Fibonacci 3 ways, and the reason why is because I do the Fibonacci series in 3 different ways here. And I'm going to, the reason why I'm looking at this is I'm just going to migrate some legacy files kind of like into a different repository. And I might even put it on my GitHub so that you can see the code for it. Um, But here is, and I'm going to go through each one of these, and I'm probably going to modify this a tiny bit just to make it a bit more user friendly. But the first thing we do, the first thing I'm doing here is importing time, and I'm just going to import time as t because I'm so lazy that I don't even want to use the time module. I'm aliasing it to t. And then I'm going to go through the 3 different methods. The first one is what I have called a brute force method, which is kind of like the method where in computing where you just do everything as much as possible. It's the slowest method, but it's kind of like fast and it gets it done. The next method is what's called the memorize method, and I'm quite sure that this is my best method. And the reason why is it's really fast. But one of the reasons that these types of things are quite fast is because the some of the computations, or not some, the computations up to a certain whatever number that you're calculating, the results are stored in a dictionary, and something like the Fibonacci series, it uses the previous information, so there's no need to do a recomputation of the information. So that's known as being memorized, and I think that I'm not sure that there's a better way actually. And I'm just wondering, I've got tabulation here as well. I'll go through that because I've probably got to remind myself. Although I think my attempt at tabulation I'm just wondering if it might be memorized as well. Maybe or maybe not. Um, and what have I got here? I don't know why I got this one here, which is a function showing that user can add a boolean and an integer. Well, I presume that we can add that. I'm not sure that that was relevant, but I might have put it in for some reason. So I'm just going to go back here now, and what I'll do is at each of these functions, I call the function, but I'm going to do it in a slightly different way, which is I'm going to do an if name, because I've been going through a lot of these, kind of like fixing it. It's the name, I call it the main guard idiom. An idiom is kind of like a pattern or conception, so that's sort of like what it's referred to. But this if name equals if double underscore name equals double underscore name, it's just checking that this file works. Now, the reason why I want to do that is because I want to have a main function, and so I want to call all of these functions from a main function, so that I don't have like I'm trying to do this to all of my code so that I don't have the script. There's nothing wrong with this, by the way, because it works, and I could actually do this common thing in VS Code, which is you can use the interactive Python, which is quite nice. It's not it's somewhere between Python code and the Jupyter Notebook, and you can run like little blocks of code. But I'm just going to do it in a slightly different way now. So I put this if name equals main, and we see here that we've got this squiggly line underneath, and that's because main isn't defined, so I need to define main. But the reason I want to do this like this is it effectively gives you a what you have in other languages like JavaScript is hoisting for free. So def function, but my function is going to be the main function, and from this function I'm going to be calling all of the other things. So now this is the main starting point of the code. The main starting point of the code. I was looking at C++, and actually the your first function that you have is main. So that's kind of like your first function in C++, and so it's kind of like a bit more C++ lookalike-y in a way. You don't have to do this. Scripting is faster. All of this stuff I'm quite sure worked. In fact, if I was to hit F5 to run it, but what I'll actually do, I'm going to do this anyway, right? Which is because I sometimes like this, which is it. This will run an entire block of code. Now the whole thing is one entire block because it goes from top to bottom, and because the if name equals main thing just this is going to do nothing because it's just going to run an empty function, but it'll run all of the rest of the code as is. So, and if I press Control Return, it will run it in the interactive Python over here on our right hand side. It's just connecting to the kernel. It's quite nice doing it this way because you get all of your data and it's all like kept in the interactive Python, and you can do certain things like if you've got variables like T1, so like T1, I can sort of like put that in and do Control Return, and it will tell me what T1 was, which is, you know, that's just the number of seconds since the epoch for this particular calculation. I wonder if I did. No, I still do T0 and T1, so it's probably it's the last one of these, whichever the last one was run, which looks like that one. In fact, I do time nanoseconds, so it's a number of nanoseconds since the epoch. I normally use seconds, so I wonder why I use now. I thought nanoseconds might be more accurate. Or I probably use nanoseconds because seconds wasn't sufficient because it was running the code so fast. But anyway, I've done it like this, but what I'm going to do now is break this up, or at least I'm going to call this function now from like a main function. So in the main, I can do something like run brute force. And then I can take all of this code here, exit out, and paste it in here, and put the tabs in. And this fib is still referring to this function here. It's visible, it's seen, because it's hoisted if name equals main. So although it occurs after the main function, this piece of code never got ran until main was run, and main was run here. I don't actually need this guard in particular, if name equals main. I could actually just delete that and remove that, and this would be sufficient without even the idiom. So I could just do that and it would run the main function. But it's kind of like a convention in Python to use, and I'm trying to modularize everything. So I'll do Control Z, Z, and Z to put it all back again. So let's go back and so I can now run this piece of code, our brute, what we're calling our brute force method. And actually, one of the things that I recognise that I can do if I'm relatively smart about it is by doing it this way, I believe that I could use a decorator, because I can use a function that calls this function, but all I want to do before it is do a calculation, and all I want to do after it is a calculation. And I just have to remind myself, or I might actually even put this on the side, because I think I've got it here. Create a decorator function in Python that computes the length of time of the function that it decorates. I'm hoping that question roughly is good enough for a standard decoration. I might attempt to do this because it'd be quite nice in the video to do that, because something extra to achieve. Here we go. We've got the time it, so it creates a nice time it function here. It looks like there's a wrapper with args, with arguments and keyword arguments. What I've actually got to do is zoom in, because otherwise you can't see the code. I'm wondering if I can zoom in enough. And I probably have to just shrink my VS Code for a minute or two so that we can see everything here. And if I do a couple more zoom ins, there we go. So I've basically asked here, create a decorator function in Python that computes the length of a function that it decorates. So import time, well, we've got that anyway. It's created this time it function, and it decorates like this. Oh look, it's actually stuck in a factorial. Oh, no, it's factorial, not Fibonacci's. But hopefully, I think this decorator might just work as is. So I could probably take that. Now I don't know 1000% because I've got to check that it works. But I'm going to take that piece of code. I'm going to minimize this all back down again because there's no need to keep it up there. So Control Shift and back. I think not Shift. What is it? Control. There we go. We'll go back down to the 100%, and I will re-expand my VS Code because I've already got it copied in now, so it's fine. Let's make that big enough so we can see the whole thing. And I can put, for example, I could put the decorating function here for the time it, and then it's got time.time, but I know that it's t.time because I aliased it because I was so lazy. There we go. And I'm wondering, print the function time. Okay, and what it's actually going to do here in the function that is wrapped is, and it's going to say this function took so many seconds to run. So I might even attempt to use it. So what I'll do first of all, we've got the if name equals main over there, and it's going to run that. So this one's going to be run out in the code. I'll probably move all of them up one by one and then do it. We've got our brute, so that was our brute force method. And now we've got our memoized method. So I'm just going to take this one as well. And this is the reason that I say that we can do decoration. It's a classic example, actually, or pattern of where you can do it. And I will explain why. So this is our memoized version, but I think it's already going to become apparent. I have to know how to spell memoized. I think it's something like this. You can always look it up as well. Control//, there we go. So commenting it is this. So you can already see, but this is repeating, and this is repeating here. So this was my old school method of doing it, with nothing wrong with this. You know, some might argue that it's clearer. I don't know. What I'll put here is a decorator function to time functions. I do that because I was doing this the above historically. First of all, because I didn't know about decorators. But the second reason is it's relatively clear and quick and easy to do. As in, you just set a T0 wherever you want it to be. You set a T1 wherever you want it to be. And then you've got T0 minus T1. So it's so fast doing it this way that you don't necessarily need to do it this way. And in many respects, it's quite complicated in a way. So I'm going to like semi-ignore and hope that the decorating function works. That's why I'm going to... I might test it on one of them. But anyway... That was a memoized one, and the third one is tabulation. So I'm going to take this one out as well, Control X, and now I just wonder, because it's a table test as well, Control Z, let's have a look, Control Z one more time, that does fib 90, okay, that's an interesting one. Because I've called the function fib, I've called the function fib again, and I've called the function fib again. So I'm going to be careful about this now. Because each time I presume I run fib. So now I've got to be careful because I probably need to call it like fib brute for brute force. So that's going to be an interesting one. Because if I call it fib brute here, I've got to change these to fib brutes as well. But really, I kind of like the reality is I do want them to be different names because they're doing the Fibonacci in different ways. So it's probably like, although it is potentially always wrong to do that. So I might change this as well to fib underscore brute for brute force, which meant that I needed to change this one and that one to fib underscore brute, and it meant that the top one here is now fib underscore brute because I'm calling that. So that one's fine. Now we've got this memoized version, and I think also I was only running, I wonder, because I'm running fib here, and I wonder if I run another version. But anyway, I've got fib_root, and actually one of the things to show, I think, is if I go over here but look at the outline and sort of like expand it, because you can see this here. Here's my time it function, which hasn't been used yet. So this is what's going to be used for the decorator. And we can see the wrapper function inside the decorator, but we'll close it. Here's the fib_root, and here's the other fib. That's I think I did. I wonder if why I did table test. Probably because I stuck it into a table and did it that way. But I don't think I need to, because it's really, I'm going to compare Fibonacci brute to Fibonacci memoized, which is a cleaner version, possibly, of doing the table test. That's probably my attempt at it. But nevertheless, we can sort of like see it there, and if it's a different function, although it's doing the same thing, like you want it uniquely named. So I will say that I had them named incorrectly before. So that's fib_root, and I go down to memoized, and therefore I will call this fib memo. There we go, to differentiate it from the other one. I've also got helper. Why have I got helper n-1? Define the helper function. Because I needed the helper function, I don't know why. Funnily enough, here's a function inside a function. So this well, I'm going to say it's decorated, but it's not. But we've got a function inside a function. I don't often do that, to be fair. Like, I think one level of nesting is acceptable, and then afterwards, what some people might argue, it becomes excessive. So that's fine. I don't need to rename anything because this is the helper function. But the reason that the helper function exists in this memoized one, I believe, is, so here's our memo. So we've got, and the memo is just a dictionary, it's a Python dictionary, and the helper function is checking if n is not in memo. But actually, there are better ways of doing that, because I'm quite sure I could do something like default dict or something like that, where it doesn't get an error. Or I think I can do, I think it's dict.get, but there's a getter for dictionary where for dictionaries where if the value doesn't exist, then it won't throw you an error and crash the code. So I might not have had to do this necessarily. But anyway, we'll keep it like that just for now, just so that everything does run. But finally, there's a tabulation version, and I certainly don't want to, whatever this thing was. So I've got to do because I've got this fib memo, actually, I'm going to go back up to the top. So I copy that, and this second fib here is going to be this fib memoized one. And I might even put in like a little print statement for each one. So print running brute force. Okay, and then at the end of it, print. And by the way, I could stick this into the decorator as well. But we'll see even if the decorator works. And so like that for finishing it, right? So we got that one, and the reason why I say I can stick it in the decorator is because I'm going to do exactly the same thing, which is this. But actually, I think the decorator is going to account for that, because we saw in a decorator it says the function .func name, and this is probably the best way of doing it. And then it took how many seconds it took. So I might not need this, but I'm going to stick all of these in anyway, because I just want to make sure that the code actually works, because I've done a lot of changes to it, let's just say. So this time it's not running brute force, but it's running memoized, and let's just copy all of this, just to get the same length of the prints. So tab there and paste that there. And finally, I could actually even make the wrapper function sort of like a double underscore or an underscore to be like a private method. But we'll leave it as an open method for now, like as a public method in Python. And finally, so we've got this, we did the brute force one, we did the memoized one because we called it memo. and the last one is this tabulation, so fib tab. And I should really comment it. Did I comment the last one as well? No. So I'll probably comment them so that they're quite, I don't know, brute force method. Although it doesn't need really a comment. Some people might need a comment because if you name it relatively well, then you probably don't need a comment. But the reason why it's nice doing this is, well, we'll see when we hover over it, because I know that in 3 or 6 months, whatever, if I ever did come back to this, I'll completely forget. I'll not memorise tabulation method now. Which, whatever that's doing, but I'm quite sure that is doing the same as the memorized method, because I think it's storing things in a, well, not, okay, the key difference is this. I know what the difference is actually. The tabulation method is it's storing the values in a table, in a Python table, but a dictionary, or a Python list, I call it a table, a Python list, but storing it in a dictionary is, I'm sure, is faster. Well, it is faster. So this method will be the fastest method. This method will potentially be the second fastest, but lists might cost you time. So, and we notice, but anyway, we continue here. We notice now that this is squiggly underscore because there's no fib method left. So this is now fib tab. And I don't refer to, so I just take that one, I'll put it here because it's fib tab. And we'll take all of this. I just wonder, because why have I got table test in here? And why do I run table test? I'm testing how tables work. Right? So I will move that out as well. So I'll X this away and move it up to the top. So somewhere like here, and this is the really annoying thing about Python or white space indented languages as opposed to curly brace ones, is when I do a paste, the first line gets indented and the others don't. So you still like got to shift tab it and tab it back and it all works, which is a horrible disaster when you're trying to, like if I'm trying to copy off of even something like Google Bard or ChatGPT, or if you're copying a block of standard code out of the web. It's annoying because you've got to go back and do the formatting. But anyway, the nice thing about it, I can show you this, is if I hover over it, it says tabulation method. And if I hover over this function, it says memorize method. And if I hover over this function, it says the brute force method. So it's kind of like a little hint. But we're probably going to town with the commenting on it. This is probably, I'm probably over commenting, but we're going to do it anyway. Let's go here and tab, and this is tabulation method. And then we want to put, so I don't know if I can't remember if I did that in, but I'm going to do this and running tabulation. And also we want to copy the print statement out, copy that, and stick it over the tab, stick it over there, so it's all in there. So now we've moved all of those methods out. We've also got this table test, which is just to test how a table works. So again, I do find that n equals 10, table equals 0. Okay, am I creating a table? Here, table equals a list times by n plus 1. I'm not even sure what table test does. So, in fact, what I could do here is I'll exit out. Well, actually, I don't have to comment it out. If name equals main, let's just do it at the moment. We won't run anything at the moment other than this table test will get run, and this one here, ball plus int, will get run. Okay, we'll see what this does. And I'm just going to hit a pass statement in here. I wonder if I can do triple dot ellipses. That looks like it works. So if I rerun this code now, all I'm going to get, the only things that are going to run is this table test thing. So it's created a table. There we go. Create a table of a first certain length. So and this was probably me playing around with here, because I'm not calling table test anywhere, and I know that because if I do a control F and have a look. I believe, does it come up? It's not coming up anywhere. I'm using it once just as a practice, just to see how to construct a table. So I'm going to keep, and this is the thing, I can keep it in here, but I don't really want to call it in the code, and I certainly don't want to call it in the script. Like if I did want to call it, I could sort of like X. I'll take it here and I'll move it into the main now, and I could put something like test how to create a list. So actually, it's a list in Python, a list of a certain length. So I'll be doing something like that and then paste in the table test here, but I actually don't want to even run it, so I'm going to comment it out now. So now, if I look back at the code now, it's just going to be a bit cleaner. I've got this timeit function, I've got this fib brute, I've got this fib memo. I wonder if I hover over, no, you don't get the comment, that'd be quite nice. So I've got these three methods now, the brute force, the memorize method, the tabulation method. I've got this function that I haven't deleted, but I'm not using, but it's called table test, and now we know what table test does. And the same thing here, I've got this bool plus int, but I don't really want to see this running. So again, I just close this out and go back here, and for this bool plus thing, function showing that a user, function showing that user can add boolean ints. Okay. X. I'm going to take that out because we don't need it. I'll put it in here just to keep the code because I'm a code hoarder. There's no like particular reason other than it just reminds us of what we've done. But tab X proof that can add a bool and an int. There we go. But we're not going to run this code because there's no need to, so control / to comment it out. So that's gone as well. Now I'm going to uncomment because I believe there's no extra bits. So now everything is just functions. So we've just got a set of functions. And our functions have got like, okay, they haven't got the world's best comments in there. You know, like in here, you'll need to say n. N is an integer. In fact, n is an int. I'll put that in each one. N is an int. So I'm type hinting. You shouldn't be putting in a float. If you put in a float, it'll crash. This is just type hinting. It doesn't force anything, but it's useful to have int because it helps without having. It means I don't kind of need to put in here. And the reason again is that, well, I'll just do the last one. Int. There we go. We've typed hinted all of them. Is that when we hover over this, we now get it tells you the brute force method, but it now tells you that it's an integer. And it returns back any or literal. So that's a bit of an interesting one because I wonder, go to definition. Okay, because I guess it's giving back an integer here, if n equals 0, if n equals 1, and here it's giving you an any. I wonder actually, I think that should be able to give you back just an integer. I'm just going to hover over this one. That gives you back an integer because helper presumably is always seen as an integer. And that gives you back an integer. So I'm going to do this extra type int, right? Because int. This returns you back in. So when you hover over the function, it's quite clean and nice now. It sort of like tells you everything it's doing. For the IntelliSense, it's a function, def fib brute. It takes one argument, the argument's an integer, and it returns you back an integer. And this is the brute force method. Likewise, here on the memo, it takes in, so it's a function. It's called fib memo. It's got it takes in an argument. The argument is n. That's an integer, and it gives you back an integer, and so forth. Same for the third one. And we've got no other spurious pieces of code now running in the script because everything's run in the main module now. So these functions aren't called anywhere because we commented them out. And I think I've got the three methods. So we've got the tabulation method. So all three of these methods now are going to run: the brute force, the memoized, and the tabulation, and nothing else is going to run. So that's quite nice. Got it to a point where we wanted to get to. So now I'm going to uncomment the if name equals main. I can get rid. I'll get rid of the ellipses because they don't need to be there. And I will do a control return to run it. And here it says running brute force. Now remember, this is milliseconds by the looks of it. This is the memoized method, and I'm hoping it's correct. And this is the running tabulation method. Now I just want to check that this is correct. In one way of doing this, I guess, the cheating way, is I might stick a time dot sleep in somewhere. Probably not in the for loop. I wonder if I did actually. I just want to make sure that that is actually 0 millisecond, but it might be because it's running so fast. And the reason why it's running so fast probably is because I'm just doing fib of 20s and 50s and 90s. So maybe that's why it runs so super fast. And the other thing is actually, hold on, let's just do a fib of, I wonder if I do a fib of 100 for each of them. I hope I don't break anything. In fact, here's another thing to do, because now I've put it all into the main and it's a bit clearer. I can do something like, so this is my only arg is n equals 100, because then if I do a change, it'll be the same change for all of them. So n, and n. There we go. I'm making this, every single point I'm making this kind of like more homogeneous and less things for the coder to change. So that we're running this on an equal basis. So again, I can do a control return. Now it's thinking a lot longer, but that's because the loops are longer. I hope I haven't killed anything, because maybe fib of 100 doing it in a brute force method. I'm not even sure. But what we can see is it's running brute force, and it hasn't finished. So I hope I haven't murdered it. Maybe I should have just started them all at 20. But this goes to show actually something. That the brute force method is really slow. But let's have a look. Let's go to here while it's running. Go to definition. If anything, okay, yeah, because this is recursive, which will be poor. It's not just for brute force. It's actually, that's why it's slow. So it's worse than brute force. I'm not a fan of recursive methods. There's a reason why. But basically, whenever you can avoid them, they're more simplistic to use. I think that's the advantage of them. But basically, it's a function recalling itself, and you can end up with a Stack Overflow because this function's calling itself 100 times, if not more. Because fib brute 100 calls fib brute 99 and fib brute 98. And fibroot 99 calls fibroot 98, fibroot 97, and fibroot 98. So you can see this whole massive thing that's going to go along. So I might kill this by, I'll hit interrupt, because I probably murdered it. And I'll even close that for a sec, because we can always rerun it. The kernel will restart. And I learned my lesson the punishing way. I will change this now 20 to each of them and do control run, and hopefully now the Python kernel's restarting because I actually had to kill it. I don't know how long it would have taken, but we're not there to wait. What we do see straight away is brute force is taking that length of time. The other ones are super fast. But I'm just going to purposefully slow one down just to check that everything's running fine. I'm quite sure that it is. But in this fib memo one, for example, I will go to definition here. I wonder if I can possibly multiply the milliseconds by another 1,000, because maybe there's some sort of fractionalized thing there. But let's just go here and we'll put in this def helper, I guess. This is fun because this is recursive as well, because it's calling helper n minus 1. But I think it's storing things in the memory, possibly. But I'm going to add in a delay, t.sleep. Okay, 0.001. There we go. So I haven't made it sleep too long. You know what? I'm scared that I'll do 2 hours. I'll stick in an extra 0. Let's do a control return. Yeah, okay, so it does work. Like I forced in a sleep. And then all of a sudden you can see with this sleep method, it's made it longer. So let's, I've basically forced the computer to wait a bit. It's got a bit better. I wonder if that helps. It does, but to a limited extent. Funnily enough, it's amazing. How many zeros can I stick in to get it to like... That's an interesting one, because it's still, even with all of this, that's potentially telling me how intensive the top one is, because with all of these zeros, you think that's nearly like 0 time. Potentially, I'm just wondering, potentially, right? But the minute I take that out, it goes back down to 0 anyway in terms of milliseconds. So we know that it is working. So we're going to take it that these two are faster, but they will be faster because they're storing things in memory. So this can be super fast, basically. The only other thing that I think that I could do is over here, I could do t minus t naught. But actually, on the memowise one and the other one, I could do sort of like times by 1. I'll do this. There we go. Just to see if not a true 0, like as if there's something in there. I'm wondering, is it that super fast? I don't know. Have I got my T1s right? Because I got T0, T1, T0, T1. No, so that's fine because this T0 and T1 starts here. So I'm not like, I'm just really overwriting the T0s and T1s from there. So that's a bit of an interesting one. And here's another check that we could do, which is this anyway. I'll take this one out. Let's just say, in case this T0 minus T1 was being overwritten, if I put the memorized one first, which I can do now, so I can select run that one first. There we go. Control return. We still see that this middle one, this brute force method, is a slow one. So I'm just going to move this back down now, which I think I can do with an Alt and these arrows. There we go. So it's back to like where it was there. It's probably easier cutting and pasting than moving blocks of code. But anyway, so there are 3 methods that are there. Now it's just time to, for the sake of it, test our time it functions. So I should be able to, over here for example, just put at time it. There we go. And I don't think I need the brackets either. I'm just going to have a little check of that one. Calling it. No, I don't need the brackets either. So I think that that's sufficient. Although, why is it giving me that? Expected function or class declaration after decorator. We've got the args and the keyword args. So I'm not 1000% sure on that one, because if I removed it, that goes away, and I should just be able to do that time it. There we go. Do I have to do that? No. Do I need to stick in an N here and remove that from there? No. So, okay, the decorator isn't working the way that I was expecting it to, and I've kind of like got it up on the side as well with this wrapper function. sometimes the things that Google Bard spits out aren't wholly correct. But time it takes a function, which is here, and that's what's passed in. And so that looks okay. What I might do, because it's a Bard error, I'm still going to try, I'm going to persevere with it, but over here it says expected function or class expected function or class declaration after decorator. That's an interesting one because I've got a function coming straight after it. Oh, I see. I need to put the at time it above it. So I don't put the at time it here. Sorry, I've got to be careful about that. X. I can now put the at time it. Apologies for all of that. The decorator goes over each one of these. I'm not a huge fan of decorators for this reason, but I mean, they're there and they get used in Python. So you could anyway, this is how decorators work now. Each one of them's time-ited. And if we hover over the time, it's a decorator function. A decorator function to time functions is what it is, and that should work. Now we're going to get what we're going to get here is the decorator is going to work, and our time it decorator, which was, well, I can just go to one of them. So go to definition. There we go. It's here. We're going to get this extra print statement somewhere inside the running memoized. Then we'll get our value that we did, our conventional one. We're going to get a second value coming out. So let's just run this, if it works. And one thing that's not great is it says this like a million times. The function fibroot took 0.0 seconds, and it said it loads of damn times. With a triple dot, almost as if it's run it every single time. But I've only run it once, so a decorator isn't going to work on a recursive function because it's going to recursively call a decorator on itself. That's an interesting one. I might do a little thing on decorators, but if somebody knows the answer to this, I presume you've got to put that function into another function in order that you don't recursively call your decorator. But that's an interesting one because I never thought about that as recursive, as an example of where decorators aren't going to be so useful. I'm going to remove this one because it recursively calls itself. I believe that this one might be fine actually because it doesn't recursively. You see, helper here is named. So this one isn't recursively calling itself, so that might be fine. And fib table doesn't call itself, so it was only apparent or only going to happen on the first one. So actually we can't, I could comment, we can't decorate the first one. We can only decorate, we can't decorate a recursive function. So what I'll do is I guess I'll just run it again now because that should have fixed it, and it has. It's running brute force. We've got no decoration, but the second one that has run. It's got the function fib memo took 0.0 seconds to run, and the function fib tab took 0. So that's quite nice because I can delete this here. We can delete all of this now. All of this goes. This goes. All of this goes on the tabulation method. That's quite nice. We've cleaned up a lot of code. Likewise, all of this stuff goes here now because it's all gone into the decorator, which is quite nice. But unfortunately for this one, run brute force, we cannot decorate. Or I wonder why I should put that comment. I'll leave it here too. Recursive functions, or at least if we decorate recursive functions, the decoration that occurs every time it's called. So I'll just go over there because recursive decoration, because the decorator is called many times. So there we go. Anyway, we've got to the point now where we're going to like run this here, but yeah, it's going to all be the same. We've got to the point now where we've got a like smaller code, but well, smaller, a clearer code base, should we say? Because now we've got a whole bunch of functions that we could, in theory, just export somewhere else to another module. We're probably never going to, so you could argue that it could always have stayed in this a script. You could also argue that maybe the decorator isn't as clear. Maybe if you're doing like 20 or 30 different functions and you're decorating them all with some sort of timer, that would be better. But now we do have a timing decorating function that we could call, which is here. We've got a time it function. I think there's time it, and here's the thing, there's like t dot, I think like, is there a time it? Time, no, but there is a time it module actually that does this, but we've got our hand built version of it, or at least our copied from Google Bard version of it from an AI thing, but that seemed to work perfectly fine. And that's really it, I think. That was an interesting one about brute force. What we could have done is we could have dumped this brute force. So I could have done a def brute force like there, int int and all. In fact, I could have put, in fact, I'll keep it even clearer, but basically, and I could have kept that one there, the brute force method is basically def helper, right? Kind of like the same thing actually, where, because this would allow the decoration, because then I wouldn't call brute force again. What would I call again? Helper. There we go. I now call helper again. I think that would solve it. It's less obvious that this is a brute force method, or so recursive. Although you can probably see it's recursive because a function is calling itself. And that's actually why on the memo one, not this one, here this looks recursive because the function's calling itself. But the difference being that it's stored all of these values in a dictionary, so it's super fast when it does it. And likewise here, is this one calling? I don't think this one's calling itself. That's why this one's fast. And I actually quite like the tabulation method, and I reckon that I didn't have to do a tabulation method. I could have probably put that into a dictionary. That would have been even faster. But now, just going back over here to our brute forcey thing over there, we can now make it recursive. So we can do at time it's. I'm just going to check on that, obviously, by running it, but what we'll see is we'll hopefully get this little thing coming up here, like this string over there, if it works. So run it, and now we see that although it says the brute force method took 0.0 seconds, that's a bit of an interesting one. Is that because the brute force method called the other methods? That'll be an interesting one. Because I'm going to time it here, and that should just be the whole length of time of this brute force method. But it also gives a 0 here, which is an interesting one. But we know that can't be the case. I find that quite interesting, and the reason why I know that can't be, because if I just hit Control Save and move this to, I don't know, 40, I'll double it. I'm too scared to go too fast. It's done it fast. 50. Is it actually running it? Is it? Oh, look, one thing we want to do is return back an answer. Actually, let's print. Let's give ourselves back an answer. We didn't do that one in any of our functions anyway. Hold on, we did return a result. That's for the time it one. Sorry. Return helper, return helper. Okay, so we want to print out our result. How about that? That would be something useful. Just to make sure our functions are giving us back the correct numbers and we're not just running them. So result is equal to that, and then print. Our result. There we go. So we now got a result of the brute force. I'm just testing it out. Let's have a look, and it gives us back none. So it's like it's not running it. So that's kind of like what I was looking for, and I'm just hoping that the memorized version R equals that, and then kind of like, let me just put it up there. Let's run that. Okay, the memorized one is giving us back a result, so that's good, that's positive. And finally, we're just going to take this same print statement and put that in here, but actually that will go into the decorator as well. R equals fib tab. And so these two are giving back results, and they're giving back the same results, so I've got confidence in that. And the top one is problematic. So let's just then, in that case, it's also got a T0 minus, so it's like literally the timing here is running this brute force function. But when we go to this brute force function code definition, it's got this inside of it. Ah, here we go. N. Right. We haven't passed n in. Int. There we go. And also, am I that stupid that I didn't actually call the helper function? So inside that, so I've done a whole bunch of mistakes, like collectively. I would have needed to call the helper function like this, a helper of n. So now when we call a brute force function, we passed in the value of n, then it does this helper stuff in here. So now it's doing all the heavy computations. I've got to move that number back down from 50 to like 20. So it's calling helper of n inside, wrapped inside this brute force, and the time it should work. So so now the recursive function is inside a function that's not recursive, and therefore, so this part is recursive here. This helper is recursive. There we go. That won't pop up anywhere outside of it because it's a function wrapped inside a function. So because of encapsulation, it's kind of like an encapsulation because of encapsulation, or scope. It's probably the better word is scope. Because of scope, this function isn't seen out of it. So we don't see, if we go to there and we go to not the main, but we go to our brute force and we see it inside. But if we do that, we don't see it outside of the scope. There's no helper outside. And the same thing for the memo one. There's no helper outside of it. So it's sort of like an internal function, a function inside a function. Not a huge fan of functions in functions, but for this particular case, we're doing it. Because now we make this one back to the 20. Hopefully, I can remove all of the other bits and bobs. And actually, so that's working now, but not working well, because these two give us back this result, and this brute force one gives us back a different result, which is rather annoying because it's almost like it's not working then properly. Because I'm quite sure. Is that T naught minus? No, 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 fine. No, no, it's still giving us back a none. Interestingly enough, and probably because one more step to do in this brute force function. Oh, it's killing me. But it's sort of like we've called the helper function and we want to return R. And hopefully, yeah, okay, I think that might be it because it returned us back a none there. So now we're returning it. I think I could just return helper. I'll keep it like that for now. I'll just run it. There we go. Oops, control return. And okay, now they're all giving back the same thing. They're working, they're well behaved. I could move this helper into just over here, control X, and stick it over there. I did because I did return wrapper there. I know that was the timer one, that wasn't what I did. But it's quite Pythonic to do that. I'll get rid of that R in a second. But over on here, I just returned. I like to create the variable inside it and then return it afterwards because it's a bit clearer. But I didn't actually on here on the tabulation. I returned table -1, so fine. I'll keep it consistent. Let's get rid of this R then because it's not necessary. That was one extra line of code. So again, running it perfectly fine. But the nice thing about now we're seeing the nice thing about all of this stuff. The nice thing about the decorator here is I can get rid of this. I can get rid of this. I can get rid of this. Then I can run the code, and we see this a lot shorter. But also, it says this fib brute took that many seconds to run, or milliseconds actually. So I've got to be careful about that. So I now go into this decorator and go here because this is going to be quite nice. I'm quite sure, wasn't that in? Oh no, this is in seconds actually because it's time. They just use time.time. So I've eliminated my milliseconds. So time.time seconds to run. That's fine. I could multiply it by 1,000. And that would give us milliseconds, but that's fine. So it took us that long to run, but also print the result. I'll do it as an F string. I can't do it like that because I can't give back the result. I was going to give them back the result in, over there, because that was the wrapper function returned result. I wonder if on the wrapper inside our function X, I can do this. Well, that returns wrapper, but I could actually do a print statement as well. That returns wrapper. And wrapper is the result. Print. I'm going to do it here. I've got to be careful about that because if I'm returning wrapper like this and I want to make another statement before, I probably have to run def wrapper return wrapper. Because going to go in this, it's going to take the function, whatever function, it's going to wrap it round, it's going to print the time stuff around it. It's got the result. Oh no, I can do the result is because it's returned the result. That's fine. I can do that because result is actually created here. So I can go in here and put print. I'm going to print 2 statements. I could add it all into one string, but I will just do it in 2 strings because it's a bit clearer. The result is results. I can do that. And the nice thing about that is it will, when we do this, the wrapper function now actually gives us back the result as well. So we don't need to now go and do brute force R, right? Because it's kind of like all in there. We don't even need to set R equals something anymore. So if I just do that, we see the first one because we were now getting the result. I could put the result for brute forces. But I guess we don't need to. So I don't even need to get something back anymore. And it's going to do it for all of them. So I can get rid of all of this. And this is the nice thing about wrapper functions, maybe, is that if you have enough repetition and enough stuff that you want to repeat, it is quite convenient because, oops, there we go. So now it's getting even better. And you know, arguably I don't even need this print statement to be done 3 times, so I'll X that one out and stick it here because we're done. Again, not necessary, but I'm doing it. And where was the other one? Brute force, memorize. I cut the other one out already. So there we go. It's giving us all of that back. And I probably don't even need to say running brute force method anymore. I'll keep that one there. I'll keep those there. But now it's quite clean. So you can see, like, we can see that the wrapper, that this decorator has kind of like done quite a nice decoration. And we've not had to repeat our whole bunches of code. And the code's quite simple. I'm nearly going to say it's simplistic. But actually sometimes, this is why I do when I don't like decorators, because all of this is coming out and I'm like, where does this, if I ask where does this come from, I have to go to there, and so I go to definition, then I see the definition of the function, and then I see it's wrapped by this time it function, so I've now got to go to the time it function to see what it's doing, and I can, so I've kind of have to navigate round to doing it. But at the same point in time, it saved me 3, 6, 9, 12, I don't know, whatever, a dozen blocks of code basically, or a dozen lines of code. We could see where, like, if there was more functionality in here inside the wrapper, like the saving would be quite big. The saving isn't that big, but I guess the code is much better. One thing that we can do now is maybe make it like 30. And we can sort of see all the numbers going synchronously, which is quite nice. 40. And now we can see it's taking time. Right, that's the recursiveness killing itself. But what I'm actually inspecting is I'm not even getting like 0.00001 of a second, and like over here you can see it goes down to like really minute fractions of a second. Like, is it really that accurate? But these ones are both registering at like literally 0 seconds. Again, I think I might have killed this. I'm going to hit Control S. I'm going to do an interrupt. I don't know if, like, you know, recursively, well, obviously recursively 40 on my things too is taking too much of a limit. So I'll keep it at that. Let's close that one down and rerun it. So we've now got Fibonacci 3 ways. Method 1 is brute force. Contains recursive. There we go. We cannot decorate a recursive functions, but we can wrap because they're called multiple times. But we can wrap them. But we can wrap it into a non-recursive function. There we go. That's what you can do. That was our way around of getting of it. So there's our brute force method, our recursive method. Hover over it, we can see everything's nicely formed. There's our memorize method. That's where it sticks all of the previous calculations into a dictionary, and it doesn't go back and do all of the calculations. It goes back and collects the ones that have already been pre-computed. Saves a huge amount of time. You can see that of the recursive nature. And likewise the same for the tabulation thing, which is sticking, I call it tabulation. I think it's because the process is called tabulation, but it's sticking it into a list and doing the same kind of thing, adding it to a list and pulling stuff back out of a list. So that's it. That's Python 3 ways. We've got decorations. So we saw some decorations in here. Here's our decorator. Here's us decorating the functions to get like some extra pieces of information out there, like the function name, how long the function took to run, which was the whole key point of our decorator in a way, but also printing out the result nicely, like multiple times. And that's it. So this video did go on for a bit longer than I expected, but a lot was gained, and I'm going to actually post this on GitHub, so I might put a link to that so you can have a look yourself. And if there's any comments that if you could do any better, there are other online methods and things, so these by far aren't the exhaustive ones. There's probably faster methods as well, possibly. If you like the video, hit the like button. If you have any comments, obviously put your comments down. And if it'd be great if you followed as well. That'd be really helpful, because the more people that follow, I don't know, it's supposed to be better. So just follow, and that's it. So I think that's everything. It'll be on GitHub.